Intro. The shocking discovery on Proxima B. Imagine a grand cosmic symphony where countless stars, planets, and moons harmoniously play in unison, filling the universe with music. Yet there's one section of this celestial orchestra that has baffled astronomers for ages. Exoplanets. These mysterious worlds, residing outside our solar system, lie hidden deep within the Milky Way among the immense collection of cosmic entities. There exists an exoplanet that bears an uncanny resemblance to Earth, so strikingly similar yet shrouded in mystery. Could very well be Earth's celestial twin. As we venture into this captivating realm, we encounter Proxima B, situated a mere 4.2 light-years away. The James Webb Space Telescope is revolutionizing our exploration and understanding of these enigmatic celestial bodies. Imagine, for a moment, your mind soaring through the vast astronomical domain of our galaxy, the Milky Way, which is home to a staggering number of exoplanets, more than a quadrillion. To comprehend this unimaginable number, consider this. If each exoplanet were the size of a grain of sand, they would not only fill the Grand Canyon, but would also be enough to form a second Grand Canyon stretching for miles. What's even more surprising is that about 20% of these celestial entities have been categorized as Earth-like in terms of their geological and atmospheric makeup. This means there's a 1 in 5 chance of finding a planet that mirrors our own Earth. And the possibilities don't stop there. Alongside these planets, there could be quadrillions of moons, rocky satellites much like our own moon, locked in intricate gravitational dances with their parent planets. If you're looking for the possibility of discovering another world that harbors life or could potentially do so, the universe offers an abundance of opportunities. Having revealed the vastness of the cosmos, it's time to introduce the masterful instrument tasked with capturing its intricate details, the James Webb Space Telescope. This celestial detective, replacing traditional magnifying lenses with advanced telescopic technology, surpasses even the most sophisticated optical tools. Its primary mirror, a massive 6.5-meter lens, is 2.7 times larger than Hubble's, enabling it to detect even the faintest glimmer of distant stars and analyze the planets orbiting them. What makes the James Webb Space Telescope a game-changer is not only its immense observing power but also its cutting-edge technology, such as infrared sensors and spectrographs. These instruments go beyond observation. They can dissect and filter the unique light emitted or reflected by distant celestial objects, unraveling their atmospheric conditions, composition, density, and even mass. Acting as a cosmic forensic tool, it can determine whether a planet contains water, organic compounds, or even oxygen. The James Webb Space Telescope's capacity to answer such profound questions elevates it far beyond being just a passive observer. It represents a quantum leap in astronomical research, providing insights that transcend the discoveries made by Hubble. If Hubble's revelations amazed you, brace yourself for a feast of celestial revelations as we turn our gaze to the complexity of the cosmos. What is Proxima B and why is it so important? One particular star in this grand cosmic performance stands out. Proxima B, discovered in 2016, this mysterious exoplanet has become a subject of intrigue, akin to a Shakespearean protagonist, filled with complexity and paradoxes. It has captured the attention of astronomers and anthropologists alike. Why the excitement surrounding Proxima B? For starters, it's practically in our cosmic backyard, located just 4.2 light-years from Earth. To put this in perspective, if you could travel at the speed of light, it would take a little over 4 years to reach it, about the same amount of time it takes for a television series to run through its seasons or for a presidential term to expire. But what makes its proximity so significant? We're talking about a universe that spans an astonishing 93 billion light-years from one end to the other. Making the discovery of a planet this close, and potentially ripe for scientific research, akin to finding a diamond in a pile of gravel the size of Mount Everest, a diamond that might hold the key to understanding life itself. In the grand scheme of the universe, Proxima B is an intricate stitch in the cosmic fabric, offering us valuable clues that could redefine our understanding of habitability and life beyond Earth. It's not just the proximity of Proxima B that excites the scientific community, but also the tantalizing possibility that it's not just Earth-like but potentially Earth 2.0. Proxima B sits comfortably in what astronomers refer to as the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls flowing, rivers, vast lakes, and perhaps even oceans as deep and mysterious as the Mariana Trench. But before we start fantasizing about vacationing on Proxima B, let's consider some of its peculiarities. For one, a single day on this fascinating exoplanet lasts a staggering 11 Earth days. Picture sunrises that unfold slowly, ushering in a new day that lingers before transitioning to midday, and sunsets that stretch on forever, creating golden hours that photographers dream about. While this may seem idyllic, it also has major implications for its climate and potential habitability. How would human biorhythms adapt to Proxima B's long cycles of light and dark? Would we need to consume far more food to sustain ourselves, perhaps eating 3 or 4 times a day? Could we even sleep in the same way as we do on Earth? Life as we know it would be both strikingly familiar and disconcertingly strange, like a riddle wrapped in an enigma, testing our understanding of what makes a planet truly habitable. How the James Webb Telescope detected an advanced civilization. Now, you might wonder how we can obtain reliable and precise data about a world we've never physically visited. The James Webb Space Telescope is more than just an observational tool. It's a multifaceted research laboratory in space. With its innovative technology, astronomers don't just observe distant planets. They analyze them using an array of sophisticated instruments that would make forensic laboratories back on Earth seem rudimentary. Through advanced spectrographs, the Webb telescope can study the light emitted or reflected by these distant worlds. Each element or compound in a planet's atmosphere absorbs or emits light at specific wavelengths. By studying these light patterns, scientists can effectively perform a remote biopsy of these celestial bodies, determining everything from atmospheric pressure and density to the potential presence of essential compounds for life, such as water, organic carbon molecules, and even oxygen. This is no longer just astronomy, it's space forensics. Rather than waiting passively for clues to come to us, we actively seek them out, analyzing the atoms and molecules that compose these faraway worlds. The Webb telescope is not just a passive observer of the sky. It's a highly specialized laboratory analyst and cosmic detective all rolled into one. It allows us to take our speculations and hypotheses about alien worlds and transform them into testable, confirmable, or falsifiable theories. By broadening our understanding of the universe, the Webb telescope is revolutionizing our perception of what might exist beyond our home planet, Earth. What experts are saying about the Proxima B find. Just when you thought we had peeled back the most sensational layers of this cosmic onion, the story takes an unexpected twist. In a science fiction-like turn of events, researchers using the James Webb Space Telescope detected something extraordinary from Proxima B. A signal so unusual that it swept through the scientific community and social networks, being labeled as a potential technosignature. This electromagnetic emission was so complex and structured that it could suggest the existence of an advanced civilization. For a brief moment, humanity's collective heartbeat seemed to pause in anticipation of a revelation that could forever change our understanding of reality. Could this signal be irrefutable proof that we are not alone in the universe? Yet just as quickly as it appeared, the signal vanished without a trace, leaving behind an eerie silence and a maze of unanswered questions. Was it simply a transient cosmic anomaly, a fluke caused by some kind of celestial alignment, or could it be something more deliberate, perhaps a coded message or even the manifestation of a mysterious cosmic essence? This lone mission cast a shadow of uncertainty over Proxima B, sparking intense debates and speculations. Was it just a passing anomaly, or part of a much more intricate cosmic narrative than we could ever imagine? The mystery persists, the future of space exploration and discovering extraterrestrial life. But wait, the story of our cosmic exploration is far from finished. The ink of this narrative is still wet, and new chapters are continuously being written. This time, it's not just ordinary scientists but visionary researchers who are leading a paradigm shift in the search for extraterrestrial life. They're not content with simply studying the signals and phenomena we've already discussed. They're taking things to the next level by transforming the James Webb Space Telescope into a sort of cosmic night vision instrument with the aim of searching for artificial light sources on distant worlds, both in their dark and illuminated regions. This endeavor holds staggering implications. Imagine detecting terrestrial-like cities glowing in the dark, their radiant lights visible across the vast expanse of space. Picture the poles of a world illuminated by the glow of an advanced civilization, its light radiating out into the boundless cosmic ocean. What a remarkable prospect it would be to discover the luminous remnants of a thriving metropolis on a distant world. The James Webb Space Telescope's potential to detect artificial light sources on distant worlds is one of the most groundbreaking features of its mission. Imagine for a moment the awe-inspiring sight of seeing a distant planet illuminated by artificial lights, potentially from an advanced civilization. These lights, glowing from the surface of a faraway world, could be the first visible evidence of intelligent life beyond Earth. The notion that a civilization, potentially similar to our own, could exist light-years away and their cities visible to our advanced instruments opens an entirely new chapter in the search for extraterrestrial life. Such a discovery would not only change our understanding of life in the universe but also spark a revolution in our technological and philosophical outlook. If we were able to detect signs of artificial lighting from an alien civilization, it would be a monumental confirmation of our place in a broader cosmic narrative. It could offer undeniable proof that humanity is not alone in the universe and that intelligent life exists elsewhere, possibly evolving in ways we can scarcely imagine. This type of evidence could provide the stepping stones for an interstellar exploration focused on establishing communication, collaboration, and even future travel to these distant worlds. What's even more fascinating is how the tools provided by the James Webb Space Telescope go beyond simple observation. By studying light signatures and other forms of radiation, scientists could start to reconstruct entire ecosystems, or even discover whether advanced civilizations are altering their environment in ways that have long-term consequences. Could we detect pollution, industrial processes, or advanced technologies through subtle variations in the atmosphere or light emissions? The possibilities are endless, and with each new technological advancement, we inch closer to discovering more about the universe's hidden gems. The quest for extraterrestrial life has now reached a thrilling turning point, with the James Webb Space Telescope acting as humanity's most powerful instrument in the pursuit of cosmic answers. Whether it's probing the atmospheres of distant exoplanets like Proxima B or searching for signs of artificial light across the cosmos, we are entering a new era of space exploration. The coming years could bring extraordinary revelations, pushing the boundaries of what we thought was possible and reshaping our view of life beyond Earth. Final thoughts and what's next for the James Webb Telescope? Let me know your thoughts in the comments box. If you enjoyed the video, don't forget to like and subscribe. The journey through the universe is one of endless fascination, and our search for celestial bodies continues to push the boundaries of our knowledge. Proxima B, a planet located in the closest vicinity to Earth in terms of interstellar distances, stands as a remarkable discovery. With just 4.2 light-years between it and us, it's not only one of the nearest exoplanets but also one of the most intriguing for astronomers. Its proximity allows for more detailed research than most other distant planets, opening the door to a host of scientific possibilities. Imagine the infinite star expanse around us and the realization that within that vastness are countless planets, many of which are so similar to Earth they might be harboring the conditions necessary for life. The more we learn, the more we understand how improbable it is for our planet to be unique in hosting life. In fact, Proxima B's discovery has prompted scientists to revise many long-held assumptions about life in the universe. The possibility that Proxima B could harbor conditions that mirror our own or perhaps host life in ways we have yet to understand is an exciting and humbling prospect. But beyond the physical proximity of Proxima B, its position within its star's habitable zone is what raises the most compelling questions. The habitable zone, or Goldilocks zone, is the region around a star where conditions are just right, not too hot, not too cold, for life as we know it to thrive. Proxima B lies comfortably within this zone, where liquid water could exist, offering the potential for life-sustaining environments. However, with the discovery of this zone comes the inevitable questions about what life, if present, might look like. Could it be microbial, or could there be more complex life forms? What would those life forms need to survive in such an environment? Exploring such questions takes us into the realm of speculation. However, the tools and technologies we now possess, especially the James Webb Space Telescope, offer us a means of moving beyond speculation into the realm of scientific investigation. This telescope provides researchers with the ability to gather data in ways previously unimaginable. Its suite of instruments, ranging from infrared sensors to spectrometers, enables it to examine exoplanets' atmospheres in detail. This could help us find critical elements that could indicate habitability, such as water, methane, carbon dioxide, or even signs of biological processes like oxygen or ozone. These tools allow us to peer into the makeup of distant worlds and ask deeper questions about the origins of life, how life might begin, and if it could exist elsewhere in the cosmos. But why stop at simply searching for water or carbon compounds? The James Webb Space Telescope's capabilities extend to finding chemical signatures that might point to more advanced or even artificial processes. For example, detecting an abundance of specific chemicals or light signatures could indicate industrial activity or other signs of an intelligent civilization. And while this is still within the realm of theoretical science, it speaks to the extraordinary potential of what the Webb telescope might uncover in the years to come. The potential of the Webb telescope is further amplified when considering how it could help detect artificial light sources. Just as we humans generate artificial light on Earth, it's not unreasonable to think that an advanced civilization on a distant planet might do the same. This aspect of the mission holds particularly captivating implications. Imagine for a moment astronomers detecting a faint glow from an alien planet, indications of a city's lights shimmering in the darkness of space. The very thought of this ignites curiosity about what other technological or societal advancements might be possible in the far reaches of the universe.